Hi, this is Dave from Open Source DIY. I wanted to apologize if you've been following the channel and I let the video drop. I was involved in an auto accident. It was really low speed and I thought I could walk it off and didn't realize quite how hurt I was. I've had herniated disc, post-concussion syndrome, and a broken kneecap. Much better on the mend now, but it's still hard to get sleep, and I've had to prioritize which projects I work on because there's only so much I can do at once. But this is a project I'm passionate about, and I'm passionate about sharing what I know and getting back to learning more myself. So I figured I don't have the full plans available yet. I will get that uploaded, but I want to do it right. I don't want to just throw the plans up there. I want to make sure that people are in a good position to print the parts and get them built. And I want to make sure that it's better prepared so I don't get hit with 1,001 of questions. That's something that has always frustrated me when I did a project. And yes, you do build grit and determination and you learn, but you also lose a lot of people that way. And I don't want to lose anybody. I'd like people to learn, to whatever level you get on the project or wherever you go with your projects. So I'll share some of what I have here. This is one of my work areas. I got a couple computers. It's pretty recent for me, Macs and PCs. I've put my 3D printer inside a cabinet. It looks pretty fancy, I guess, but it's actually just off-the-shelf plan that I printed out myself and put together. I think it's a IKEA lac. I'm running a Prusa Mark III S. Another project that I haven't gotten to because I've been not fully recovered is down there in the corner. I ambitiously ordered a multi-material kit that changes the filament automatically. It gets to be more important when you're printing some bigger prints because it's pretty frustrating to run out of filament like 90% of the way through a print, or it sounds like, well, just use a new roll, but you do that a few times and you end up with 5 or 6 partial rolls that you're never sure how much is on them. So I'm looking forward to getting that kit put together so that I can resume prints by changing the filament in the middle of the night automatically. That would be really, really great, economical, and sometimes I don't care what color the parts are. I've got a lot of filament, so the two main filaments I run here, I've run a lot of different filaments at work, but I run PLA and I run PETG. So PETG is I think it's a glycol modified PET. So PET is a plastic you see really often in soda bottles. That's a great use of it and all over the place. A positive is it's very ultraviolet resistant. So a lot of plastics break down when they're out in the sun. And it also has excellent creep strength, PETG does. Creep strength is, let's say for instance, I'll show you something here. I made this stand. My wife does work from home and she uses a green screen. She teaches English to kids in China. So I made this and it holds some shop lights. I won't turn it on because it's blinding, but it works really well. So here I've got a clamp and these screws, I just put a little bit of tension on the table so I didn't have to put a bunch of screws into a nice work desk. The problem with materials that have poor creep properties like PLA is that when you tighten this, creep is that under pressure, this will eventually deform. It's kind of like taffy. If you remember taffy that you chew, if you take a stick of taffy and it seems like a hard candy and you lean it on the table over the edge, it'll eventually look like this by the end of the day. It's not that PLA is bad and PETG is good. It's not really that simple. But some of the parts that are involved in the print are printed out of PETG and some of them are printed out of PLA. And my point in telling you this stuff isn't to burden you with random knowledge. It's because it matters. And if you're going to get good at things and learn about them, well, these are some things that you could learn about. And they're interesting. So PETG, and there's many different varieties of PETG. There's many different varieties of PLA. They're heavily influenced by the level of moisture that's in your print when you're printing it, what your printer settings are. There's many different formulations from the manufacturer that are all different. Some of their claims are, you have to get everything exactly in the window to get the great properties. And if they're off even a little bit, you end up something not even as good as just standard cheap printer filament. So it's not as easy as just spending your money, unfortunately, on this. So why use PETG? PETG has pretty okay strength. It's not always weaker. It's not always stronger. It's pretty good. On average, it's not as strong as PLA. The tensile strength is not as good. On average, it's also more difficult to print with than PLA. An example is bridging. So bridging is, and I didn't print this whole table, but let's say that I printed this black part here. Well, I print this, and it prints this, and then it prints here, and it prints here. It's printing on the way up, right? Print this, print this. Well, when you get here, you can either put supports everywhere all along here, or if your printer's set up well and you've got filament that allows you to do it, you could actually print from here to here, and it'll sag just a little bit because you're just free spanning. So generally, you can get those settings dialed in, or in my case, I've got a printer that a lot of smart people have done a lot of hard work on, which makes it very easy for me to use. That Prusa Mark III's has really good parameters right out of the box, and it's got some other features, like it's got a couple fans. So right here, this cools the nozzle, or it cools the hot end. So down at the bottom, it's like a glue gun. And then up here, there's some gears that are pulling this through. I'm going to describe them as gears. I know they're not. So this is a stepper motor. It turns, it pulls the filament through. But something special is this. This fan right here is ducted, and it blows on the filament as it comes out of the nozzle. So the benefit of that is you don't want to cool off the filament, but on the other hand, you don't want it to stay hot after it's out of the nozzle necessarily, not very hot. So if you're cooling it as it's coming out of the nozzle, you can bridge pretty far with it, which is nice. You don't have to spend all your time and materials printing supports, and it opens up the design space. So you can have hollow features that don't have the supports in them, and it's just some general benefits. So PLA for some things, PETG for others. There's certainly more to learn. There's some great channels that do a whole bunch of work, like CNC Kitchen. They even anneal and temper the filaments and all that. That's great, and I hope it really goes somewhere. But for now, I try to make my designs work with stock parameters on widely available printer formats and filaments. So another thing I figured I could explain now, I'm still needing to get that site up, is RC controls. That's something that I have tons more to learn. But I learned enough about them to learn that I didn't save any money buying cheap stuff. So I made, well, I don't know if it was a mistake at the time. It seemed like a good idea at the time, but in retrospect, it was a mistake. I bought a controller and a receiver that did, not this one. I bought one that did everything I wanted it to do. But I built that project and it was a success, or at least a partial success. And then I wanted to build something else. And then I was limited. So what I wish I had done was buy a better controller up front, and then I could use it for multiple projects. I could either just move the receiver over to another project, or I could just buy another receiver. There's a whole number of things I could do, but instead I had maybe not the greatest controller and a sort of limited receiver, and then you end up having to buy it twice or more. And there's other things too that I don't have set up yet on my mower, but they would be nice to have, and I figure I'll just explain them. So this is the TX transmitter, TX. There's also the RX, which is the receiver X, we'll call it. So TX, RX. How do they talk to each other? The FCC sets guidelines so that, you know, when one of the FM radio stations starts playing a song, it doesn't make your remote control lawnmower go crazy. And also at the same time, when I'm operating my remote control lawnmower, people can listen to whatever it is they listen to, and we don't interfere. Usually these operate pretty close to home Wi-Fi radio frequency. It's pretty close to it. There's ones that operate a little farther, a little nearer. There's all different frequencies, but there's also different protocols that they communicate with each other. They used to be more open, but now they're more, I don't know how to exactly to explain it. Some of them are encoded, some of them are digital, some of them are analog, but they're safer in that they don't suffer from as much interference. So I don't know if you had these when you were a kid, but when I was a kid, you get an RC car for Christmas, if you're lucky. I did once. And then you play with it, and then it's doing nutty stuff. And then you see the neighbor in their driveway playing with their RC car, and you figure out that they must have, the Duracells, and you've got the Rayovacs because their controller is transmitting a lot further than yours, and it's making your car go nuts. That's what happened to me. So, that wouldn't be ideal for the models that we have now. At the time, those are the kind of cars you drive them forward, and when you back up, they turn always the same way. So things now, there's a lot of channels involved. You can get drones, you can get all kinds of crazy stuff now. And that used to be less common. So anyway, what controller would I recommend? If you've got the money, there's a controller made by Team Black Sheep. That is hands down the way to go. They've got a pro model. It looks like a PlayStation controller, and the toggles here, and that's not what we call them, but I'll call them toggles, they fold down so they don't get broken or damaged. So it's really nice. It's got a rechargeable battery. It's got like a mile range. The thing's awesome. So that's what I would recommend. The next one I would recommend for any project, really, this is a Jumper T12. I did make a mistake buying a controller that looked really similar to this, and it was from, a more recognized brand, and it was from an RC car shop and everything. But what I learned was that it wasn't as compatible. It sounded like it was, but there's so many different frequencies and protocols and all sub-frequencies and sub-protocols that it looked like it had it, but then you had to add an extra TX module onto it. So I'll show you what that means, roughly. And again, this is a general overview. There's a bunch of RC channels that have just so much information. It's incredible. So your main transmitter, usually, but not always, has its own radio in it. So you don't see anything in here, there's a radio. Then in this slot here, you can buy another radio and plug it in, and you end up with a couple antennas. So this one, it just has this dumb box just to close up the hole, but it doesn't interface with those pins. So why would I recommend this one? Well, it's fairly inexpensive. It's a nice form factor. It does allow USB charging, which I find to be very convenient. So I can plug a USB cord into this, and it'll charge the batteries. That's nice. Also, I was able to, kind of a DIY, be super careful when you do this project, I was able to break open an older laptop power supply, and it had round cells in it. And I took the cells out and I tested them to see if they had any voltage. And I charged them on an RC charger, and they seemed okay. The capacity is okay. Some of them weren't good, some of them were. So these are 18650 cells. And when I got them, they had really thin sheet metal strips that are spot welded on here, and they're all joined together. I just cut those off with my wire cutters. Another thing you can do if they're not fully charged and you're, willing to take some amount of risk, don't do this over a carpet or in your house. I did it outside with goggles and gloves, but you can take needle nose pliers and grab that tab and twist it. It'll peel off, and then you end up with these little prongs around the spot welds, and you can just fold those down. But anyway, you don't need to buy 18650 cells. The ones that I was able to scavenge, this controller works for hours and hours with those, and when I need to charge it, I can just charge it off this. so not a big deal. So two of the bigger reasons why the Jumper T12, it's a multi-protocol TX. So if you look up YouTube, there's a lot of people that have a great depth of knowledge on this controller, and you can find out how to program it to control a great many drones. I was also able to use this out of the box, plugged in through the USB, to run a drone simulator. So a drone simulator is great because I've got kids, and also I've got me and my wife. And if you add up the number of crashes it takes to learn how to fly a drone, anything more than just up and down, it gets pretty expensive. Even just buying propellers and paying for shipping, all that for me takes the fun out of the hobby. I like working on it. I like learning how to change props. I don't mind buying things that I need, but to break all those props and, be looking them up and placing orders and buying all these props, it was actually more fun to get a drone simulator and become more proficient in the controller. So you actually get a drone and you fly it around in the simulator, and there's training things. So there's a bunch of those available. So in the absence of having the RC mower for you, I would encourage you to, something you can do right now that's actionable, that'll put you way ahead in the hobby. Learn about controllers a little bit. Look up PWM, which is pulse width modulation, and PPM, which I don't remember what it is. I think it's pulse position modulation. So it's, where is the pulse and how long is the pulse? So they're competing technologies. You can learn about that, and you can also get the controller, get a drone simulator online, and learn how to fly a drone. I was able to get one, I think it's called DRL, Drone Racing League, that works on the PlayStation. We have a PlayStation 4. Those are pretty inexpensive now that the bigger one came out. And I got a drone simulator for the computer, but we don't have a really souped up computer. We've just got laptops here. And it turns out you need a pretty hot computer to run the drone simulator and have it be responsive in a way like where you can actually learn from it and get good reflexes on it. And the PlayStation, you can get one for less than $200 if you look around. I want to say the game was 30 or 40. And then you can learn how to fly a drone in the winter at any time and hand the controller to your preschooler like I did. And I have a preschooler that can fly a drone. So there's value there. And then when you have this, then when you build your mower, you can program it to run your mower. When you buy drones, it'll fly most drones that you would buy. It'll do the Baofeng protocol, which is what a lot of the really inexpensive Chinese drones are, or Beifang, or however you say it. And it'll do some of the 8-channel stuff, which is quite a bit more common. And it'll do some of the specialty things too. You might have a hard time finding this controller. I think I got mine from Hellination, but there's a number of excellent stores. There's one, I think they're in the Carolinas. They're an independent store. They're fantastic. But there's quite a bit of politics involved in the controllers. This is another thing I learned. Some of the brands just outright told stores, if you sell that controller, they figured out our protocol and it'll communicate with it, and we don't like that. So we're gonna monopolize. We're gonna say we're a monopoly, and if you sell that controller, you're not allowed to sell ours. I don't like that very much. I think maybe they could just make a better controller and compete. They're all made in China, which is sad, but it is what it is. So why not make a better one in China too, instead of complaining about it and forcing people off the shelf. But grab one of these, bust open some laptop power packs, get a hoverboard, figure that out. You're going to want a multimeter. You're going to want an automated battery charger that shuts off at different voltages. There's plenty of those available. And I'm going to get cracking on getting that maker site up so that you guys can start printing parts for the mower.